Hello, everyone, and welcome to Latest Advances in Plastics. My name is Daniel Patterson, and I'm an application engineer at aPriori. I'm joined by Alex Herbert, Sales Director. This technology showcase will consist of an approximately 10-minute demonstration and 5 minutes of questions and answers. We plan to run this session 3 more times so that you can attend multiple demonstrations during this hour. Before we begin, just a few housekeeping notes. The attendee lines will be on mute throughout the session. We will be recording today's session and making this available to everyone who has registered for the event. It will be available on the event website within 24 hours. We'll be utilizing the chat panel within this meeting for questions. The moderator will bring forth questions during the Q&A session at the end of the session. You can also feel free to schedule time with me via the meeting scheduler on the event website near the chat panel. Choose people, select my name, Daniel Patterson, to schedule a meeting with me. Alternatively, you can use the request info button on the main showcase page to have someone reach out to you. So let's begin, and I'll start out with a brief PowerPoint demonstration. So just very briefly, imagine what if designers could quickly assess the cost of multi-shot, 2-shot, and 3-shot, and insert molded parts directly from their 3D CAD model? Alternative designs could be compared to determine the most cost-effective option. Is it more cost-effective to do this as a 2-part assembly that's snapped together or screwed together, or is it worth it investing in the tooling to produce this as a multi-shot component? Manufacturing teams could evaluate various routings to optimize the process for molding. And then finally, sourcing could be armed with the should cost data to facilitate supplier negotiations. So with that, I will switch over to aPriori, and we will go through a demonstration of 2-shot and insert molded. So just like all of the process groups within aPriori, our insert molding and multi-shot molding rely on the 3D CAD model to extract the required data for generating a cost estimate. So when I point to the CAD model, it can either be a multi-bodied part or an assembly file. aPriori will automatically recognize that, and then we just need to choose the appropriate process group. So if we're looking at pure insert molding, our assembly molding process will capture that. We could then have the option to set our digital factor. We'll just keep it with generic aPriori USA. And then we need to pick the material. And let me pick my material library. We'll pick USA for material library for this component. And then we'll pick our material for that main molded component. We do have the option later on for picking the material for the insert molded component if required. So I'll pick my nylon type 6, 30% glass. And at this point, we're ready to generate a cost. This is a connector. We have our plastic body with 4 conductors modeled in here. So I'll go ahead and click cost. And what aPriori will do is it'll go through, evaluate this model, and then break it out into the individual components. So here I have my fuse connector body, and I have my inserts. So what aPriori did automatically is it looked at the geometry of these components and took the largest volume component as that as the molded component. The smaller ones, in this case these connectors, were automatically assigned to pick and place. We defaulted to manual based off of our annual volume, but you do have the option of changing this to a robotic insert pick and place as well. We then are molding our component. So we're going through molding our component based off of this breakdown of geometry. At this point, we do have the ability to go in and actually set those subcomponent costs if we want as well. So we could apply cost for this conductor in here. We could actually cost this out within aPriori. So we have these conductors for them. We could go through and generate a cost in sheet metal for this, or I can just run this in the background. I can say sheet metal. We want to cost this out as a copper component, and we'll say that we're doing 55,000 of these per year. So I can let that run in the background. But if we come back over to our cost summary, we can see that we have a full breakdown of costs. We're coming in at $1.42, including our tooling costs. So we've gone through and calculated tooling based off of the annual volume of this part, the number of cavities that we're assuming, and we're using that just like from the bottom, from injection molding in just the same way where we're calculating the tooling cost. So I ran through, included my conductor cost in here. So aPriori came back for these 5 conductors. We're looking at 39 cents for these 4 conductors, rather 39 cents. So this brings our total cost to $1.81. We're still the same capital investment, but we now have that calculated up. You could have more than one insert picked in place. We would calculate the time and cost for that as well. And then coming over into our multi-shot molding. So similarly to the insert molding that we just went through, when you open up that multi-body part or assembly, you have the option to pick your different process groups. For multi-shot molding, you want to pick your assembly plastic molding process group. So I'll pick my assembly plastic molding process group. We then can select our digital factory. We'll keep it at aPriori USA. And then importantly, we need to set our stages and our materials. So aPriori's automatically understood that there are multiple components in here, and we've applied the largest volume to be done in the first stage. We can set the material for that first stage. Maybe it's a nylon type 6, 30% glass. We'll pull in the cost for that material as well as the manufacturing parameters, just like insert molding and just like injection molding. And then for this second bushing, we can say we actually want this to be molded, and both of them. There's one on the underside as well. So we'll set that to be molded. And then we'll pick one of our TPE materials. So as part of the addition of the multi-shot molding process, we've added in these TPE, TPA, TPO materials, for example. So we'll pull in their molding parameters as well. So I'll set that for my bushings. Molded, we're ready to go. So we can update our annual volume or keep it just like any of our other costings. So I'll go ahead and click cost. And then what aPriori will do is it'll go through the full geometry analysis here to understand, based off of those inputs, what's the most appropriate draw direction. It's understanding the accessibility at each stage. So it's understanding how the part would go in and out of the mold based off of each individual component here. So it's really doing a thorough analysis based off of the information that it has from the geometry of the model. So when it goes through this, it will then also take into consideration this routing. So within the multi-shot molding, we have the ability to cost out not only your multi-shot process, but also an insert pick and place. So like what we saw with insert molding, you do have the ability to have molded in inserts. So these can be either manual or robotic. We'll default to a 6-axis robot for the multi-shot molding, given the high volume nature of multi-shot molding. So, but you do have the option for picking either a 3-axis or a manual. And this will drive your total cycle time, so that you get a representative cycle time based off of producing your part. So one thing to note with the multi-shot process, we will automatically calculate the number of stages, and then we do have it broken out into 2K and 3K machines. So depending on the number of stages, we will correctly assign the machine to process this part. So while we were talking, aPriori's run through. It's generated a full cost, $27,000 of tooling, $2.54 for our total cost. We're calculating material for each of the stages. And if we were to look, we can see specifically what's happening at each stage. So we have our main housing being done in our first stage. And then at the second stage, we have our bushings being molded in. So with that, I will pause. Any questions that came through, Alex? Any questions live right now?
We didn't have anything come through. I guess if you're still on and have any questions, feel free to type them into the Zoom chat. We can answer them there. But But I guess, Daniel, one thing that has come up recently is in terms of what types of materials does aPriori support, and what if a material is not in the list that we have in there?
Yep, exactly. So what we saw for our materials, we do support all of the out-of-the-box materials, your ABS, your nylons, polypropylene, all the materials that we've supported in the past, as well as the thermoplastics, the TPEs and the TPOs. We support those as well. So, and in addition, if you have your own material resin, we know we're not going to have 100% of the thousands of resins out there. You always have the ability to add in any of your own resins.
Okay. We just had another one come through. What aPriori version is this available in?
This is aPriori 2020 R1 SP1. So it was just recently released.
Very good. I guess another one too to elaborate on is, can you control the order of molding?
Yes, you can. So that was that option within review and assign. So if you wanted to control and move components up and down, if you wanted to do these first and then the housing second, you always have complete control over here. So, and then if you wanted to separate out, so right now we're doing those 2 bushings in one stage, you can always separate those out into different stages.
Very good. I think that's all we have. If there's any other questions, feel free to type them in and we'll get to them. Otherwise, as Daniel said, feel free to connect with him. Actually, we got one more, Daniel. Can this process do vacuum molding?
Out of the box, it's not set up for vacuum molding. We could have a follow-on conversation to understand your specific vacuum molding. We do have a process group for vacuum drape forming and a sheet plastic process, and we do support a lot of different plastic technology. So we can definitely have a conversation around that.
Okay. Yeah. So in that case, feel free to connect with Daniel directly, or feel free to reach out to myself, Alex Herbert, and I can certainly connect you with Daniel in a subsequent meeting to review any specific details. And again, encourage you all to head back to the showcase floor and join some of the other sessions that are going on concurrently. So again, thanks everyone for joining, and hope you've enjoyed the rest of the conference.